Earth is in a state of decay, and space exploration is the only way out. It's up to a team of the greatest scientists and engineers to answer humanity's most important question.
What?
The theme for this year's design project was Mission to Mars. Our objectives were to collect rock samples by pulling them back into our starting area, clear out radioactive materials of our zone, land spacecraft safely, collect astronauts and rovers by knocking them into our zone, and planting a flag on top of the mountain ridge. When coming up with the final design for our machine, there were several things we really focused in on. First, dimensions. We needed to make sure our machine fit within a 12 by 24 by 18 inch box. If it did not fit within that box, we'd be disqualified. We also need to figure out how to cover the distance from our starting zone to the mountain ridge, which is where most of our points would be scored. The next thing we focused in on was scoring points. We decided to place a flag, collect rock samples, rescue astronauts and rovers, and land spacecraft. We did not go with clearing radioactive material because the points that we could receive from that did not outweigh the space that it took up in our machine. And lastly, we focused on safety. We needed to make sure our machine didn't injure any bystanders, damage any of the opponent's machines, or damage the track.
The morph chart displays various solutions that were discussed for each individual subsystem. Many solutions involved extension arms, sweeping arms, and mechanisms involving mousetraps. Others were either too complicated to be built within the period of work time, such as a robotic arm, or too powerful to be handled correctly, such as a mousetrap catapult. Ultimately, it was decided that the extension arms and sweeping arms would be used to build the system, along with pneumatic cylinders to extend these arms.
So our first subsystem is the rock collection. It's going to be shot out by the actuator and pneumatic here. It's going to get shot out. These flaps are going to swing out. It's going to roll over the rocks. All these flaps are on hinges, allowing the rocks to pass underneath. But when they drop down, they're not going to be they're going to be stuck when it tries to pull back. It's going to get pulled back by this string, which is attached to our motor. It's going to come up. The wheel here, along with the hinge in the back, allows it to go over uneven surfaces, which means that these will stay the same distance from the ground even when it's coming up on the lip. And the problem we had with our first run with it was that the motor ran for too long and we got DQ'd. So now that it comes back, it's going to come back and it's going to hit this switch right here. And it's going to cut off the motor.
Alright, so the second subsystem we have, in addition to the rock collection, is the mountain ridge subsystem, which includes the three main point scoring tasks that we go for every time on a very consistent basis. So in this case, we have the flag, which is raised over the spinning cylinder on just every time we get those points consistently, and then also this angular block, which will push the rovers and astronauts into our zone. Then also this solenoid, which is released by the limit switch getting hit in succession, which will launch the squash balls, allow them to roll into the safe zone. And that basically sums up the system. It works on a very consistent basis. It's constructed very rigidly so that it will go to the same distance every time and accomplish those big point scoring tasks and tiebreakers every time.
3, 2, 1.
The first round of the competition was our worst round. We prepared our machine by pumping air pressure in the tank, stabilizing the extension arms, inserting the spacecraft behind the solenoid, and folding back the flag. However, air pressure was lost prior to the start of the round. As a result, the arms did not extend out for either the rock collection subsystem or the astronauts and rover subsystem. Fortunately, the motor activated, saving the machine from disqualification. Unfortunately, our final score was negative 48 points due to no radioactive elements cleared from the zone, putting us in fourth place.
For round 2, we were told that we were illegally securing our flag. We had to make some adjustments, and these adjustments led to our flag flying out early and not scoring us any points. Also, we were unable to land any spacecraft as our solenoid was under too much tension and didn't release any of the squash balls. Our rock collection worked well, collecting us one full rock. Our astronaut and rover retriever also worked well and got us one full astronaut. We ended the round with negative 2 points. Steph, you dirty little liar.
Team what? Team what?
Oh no. Hi, Billy Mays here.
Go.
Billy Mays here. We are Team 1 and this is our machine. We're about to break it down for you. I'm not even in the frame.
So, a rock collection subsystem
Let's try again.